So far you've learned about motors and about electromagnetic induction, and we've also looked at how to combine these ideas into the DC generator, the dynamo. We use AC in our homes though, so what we need to do is to understand about how the AC generator will work as well. I'll start off by explaining how we build one, even before we actually understand exactly what AC is, and then in another video I'll go into why we want it. Actually, before that even, let's review the DC motor and DC generator, which you can see here. The motor worked by electricity flowing from the cell to the brush, across the split ring commutator, round the coil to the other side of the split ring commutator, through the brush and back to the cell. The generator had the same construction, but we turned the handle to generate an EMF and current. Due to Lenz's law, the current opposes the motion, so it is opposite to the motor. If that's not clear, go and review it, as I'm going to move on now to the new model, the AC generator, the alternating current generator. First off, spot the difference. What has changed from the DC version? This is thinking time. There's still a big magnet and a coil. The spindle has a handle to let us turn. I've got a voltmeter and there's a commutator, but it's not split. Let's take a closer look. This commutator has two complete rings and it's called a slip ring commutator. It's called a slip ring commutator because the two rings slip over the brushes. But importantly, they stay in contact the whole time. In fact, if we animate this, you'll see that the slip rings stay in contact with the same brush and the same arm of the coil all the time. As the coil turns 180 degrees, it still contacts the same brush. This is going to have a big impact on how the electricity flows, so let's go back to the big picture. Here we can see the whole thing, so just take a moment to look over it before I start turning the handle. Here we go. At first, watch what happens to the current in the coil caused by electromagnetic induction. It's the same as the DC generator, exactly the same. All we've got is that magnet and the coil turning. The change is in the commutator, remember, which controls how that electricity reaches the voltmeter. I'll turn that bit of the animation on now. If we plot a graph of voltage against time, it would look like this. That's a sine wave. Okay, so going back, the voltage was 0 when the coil was vertical, perpendicular to the field lines. This is because the coil is not really cutting the lines up there. It's just passing across, it's not cutting them. The voltage is maximum when the coil is horizontal, perpendicular to the field. And this is because the coil is cutting across the field lines the fastest here. The AC generator is incredibly important because it produces almost all of the electricity that we use today. In this lesson video, we've looked at how to build the generator and why it produces alternating current. In future lessons, we're going to look into why we actually want that in the first place and how we integrate it into the national grid, the power system that supplies electricity to the whole country.